Okay, welcome to today's lesson. Today you're going to be able to learn to identify and evaluate expressions. This being your first lesson of our second unit. Write your date down and page number with your goal before moving on. Here's your warm-up. Go ahead and solve these, and when you're done, come back. Please remember what we learned about order of operations. Groupings, then exponents, then multiplication or division, and then addition or subtraction. Good luck. Okay, here are the answers you should have had. If you got these all right, give yourself a pat on the back. If you got any of them wrong and you don't quite know why, make sure you come see me so I can help you work through the process. Do want to point out for number 3, you're going to start seeing this kind of thing where you see a number next to parentheses. I hope you caught on that that means multiply. So I have two questions that I've kind of proposed over here. Question 1, question 2. I'm going to give you a second to answer those in just a little bit and tell me what you think you notice about those. But I want you to realize that what we're going to be doing is a lot of work called plug and chug. So an example I have written down here says inflation is the rise in prices that occur over time. For example, you would have paid $7 in the year 2000 for something that was only $1 in 1950. So over 50 years, inflation went up $7 per $1, a ratio. So with this information, you can convert prices by making a table. So our ratio is 1 to 7, meaning 1950 is the 1, 7 is the 2000. So we know in 50, if you spent $2, that's 14 in 2000. 50 was $3, 21. So really, we put a variable down here to represent any single number you spent in 1950. It could be 19, could be $30, could be $60, could be $21. What we've realized is all you're doing is you're creating this expression, P times 7. That's an expression, it's an expression that's used over and over and over. So answer 1 and 2 for me before moving on. Here are a couple of vocabulary words I'm going to want you to make sure you copy down in your notebook. One thing we've talked about already, and you've probably seen on Compass and all these other things, is this word variable. All that means is you're using a letter or some sort of symbol to show that any number can be put into that spot, depending on what you have. Everything else in your expression is called a constant. Again, if I'm putting brackets around it, write them down. A constant is something that does not change. So in the example we looked at where we were saying everything in 2000 was 7 times the price in 1950, we had an expression of 7 times P. 7 was the constant, and variable was P. Constant and variable. You can always put that down if you want as well, but get those definitions down before moving on. Now, let's talk about the word expression itself. Remember, the difference between expression and equation is simply that expression is not having an equal sign. But when you use an algebraic expression, that means you're containing one or more variables that may contain the operation symbols. So that's the one thing I do want you to write down. Down here where it says to evaluate, that's basically solve the problem. You're going to see the word evaluate quite a bit. Just know that means solve. Now, this table I do want you to include in your notes goes over what an algebraic expression is compared to a not. The big difference you'll see is algebraic expressions, they have variables, okay? Algebraic expressions are not ones that have just whole numbers. These are just called expressions, okay? Put those down so you can see the difference before moving on. Last set of notes I have for you today. All you have to note about these is different ways that you're going to see multiplying and dividing written. So if you look at x3, that can get confusing. Well, it means x times 3 with our variable and our constant. These are the ways you're going to see them. X with a dot, you're going to see that a lot, and you're going to see this one, 3x, where you put the number next to a letter. That means you're multiplying. We had something similar to this for the warm-up. You're going to see those as well. For division, you're going to see them mostly written like fractions. That's a very common thing. So just be aware of those things. You don't actually have to write them down. Just know that you're going to be seeing math written like this basically the rest of your career. All right, so I have two practice problems I'm going to go over with you. The first one I do want you to write down in your notes because we're going to be evaluating algebraic expressions. I want you to put this table down. So basically what we're doing is we're trying to find what's going to go in this box and what's going to go in this box. Now we're given an algebraic expression here because we see a number, constant, and a variable, letter. Okay. What we're going to be doing is we're going to be doing some plug and chug work. What does that mean? We're going to take the number in the column that shows the y and we're going to chug it into the answer. So here we did 16 into y, which is the same as saying y times 16. And that's how you're going to solve the other two. You just put 27 in for y, multiply by 5, and put 35 in for y. So when you do that, what answers do you get? Glad you asked. Here they are. 27 times 5 is 135, and 35 times 5 is 175. Make sure you have that table down. I don't care about all my writing on the side or the bottom, but you need the table, the title, maybe even writing plug and chug before moving on. All right, here's the second one. Now this one may look a little more confusing, but it's still the same thing. Plug and chug. We're given numbers that represent z. You have to plug those into the expression here. But you probably notice here we have an exponent, 4 squared. Before you start doing the work, you're probably going to want to solve that first because you know order of operations says we need to solve that. 4 squared is the same as 4 times 4, which gives you 16. That helps simplify the expression before having to evaluate. So really what we're doing is we're plugging in 45 for z and 60 for z, and we're just going to then divide that number by 5 and add 16. And if you do that with 45 divided by 5 plus 16, you'll get 25, and 60 divided by 5 plus 16 will give you 28. So again, you don't have to write this one down unless you feel you need to. So it's your turn now to show me what you learned. I want you to be able to fill in these tables in your notebook. Give me the answers on the video. And when you're done, come back. We'll see how you did. So hopefully your tables look like this with the same answers in your notebook. If they do, give yourself a big pat on the back. You did a good job. If not, make sure you come and see me so I can try to help you. With number 2, hopefully you saw again you have 2 cubed, which means 2 times 2 times 2, which would give you 8. Hopefully that made it a little easier. And remember, when you see a variable next to a letter, that always means multiplying. So we're basically multiplying 12 times 8, the constant times the variable, and then 12 times 9, and then 12 times 10. All right, your second practice problem that I want you to put in your notes, remember, put the title, and here we're looking at 2 variables. So a lot of times you're using 2 variables, it's probably because you're using some sort of formula. So if you're trying to find the area of a rectangle, remember that expression is written as length times width. So in our problem, we're told that the width is 4 for every single one. So I put 4s in that second column. But the length of all of these, or how long it is, could be 3, 4, 5, or 6. So when your table is neat and orderly, you can see that you're just going to do 3 times 4, which gives you 12, 4 times 4, 5 times 4, and 6 times 4. Well, 4 times 4 is 16, 5 times 4 is 20, and 6 times 4 is 24. So you're going to be doing an example problem in just a second after you copy this down. I'm going to want you to make the same kind of table to be able to solve that problem. And to help you, I already created the table for you. Just need you to solve for each expression of length times width. Come back when you've solved these properly. And hopefully you received these answers that you see right up here. If you did, give someone a high five and show them that you really know what you're doing. Okay, please complete your box of thought in your notebook. Answer these 2 questions, full sentences, and then put a box around it. And here is your quiz. Just 2 questions, and basically you're filling in the tables. So go ahead and put the tables in your notes. I'll be looking for that when you're done. And that's it for this lesson. See you next time.